My presentation, how subsurface waters record the Earth's history. Geologists learn the history of the Earth by studying rocks. The use of the composition of groundwater for this purpose is negligible. At the same time, the history of water on Earth reflects the most important events in the history of the Earth itself. Why there was a problem to use the chemical composition of underground water to determine the composition of the waters of ancient basins? Well, as we know, subsurface water can record the evolution of the Earth's crust if they inherit chemical composition of the surface water from sedimentary basins. Some scientists propose that the salinity of the ocean, 35 grams per liter, was constant during the Phanerozoic. It accepts that all the evaporite minerals found today in sedimentary rocks were present in the dissolved form in the ocean. From its inception, we can calculate that salinity of Erie Ocean was about twice today's salinity. That's 70 grams per liter. Or another hydrogeologist, Holland, roughly estimated that the average salinity of the Phanerozoic seawater was no more than 30% higher than today. That is, it was less than 45 grams per liter. Salinity of underground water for many ancient basins is more than 250 grams per liter. This is in 7 times more than modern ocean, modern sea ocean, water of ocean. And Jeffrey Harner, American hydrogeologist, said that there are two particularly perplexing problems. The first, why the water is as saline as they are, especially in basins apparently devoid of evaporites. And why the relative proportions of major dissolved species are unlike those of any known surface marine water or brine. It's very great problem to explain the hypersaline composition of brines. The origin of salinity in fluids from many sedimentary basins. Salinity in fluids from many sedimentary basins has historically been attributed to physicochemical factors, to evaporation, and so on, and to geological factor, dissolution of evaporites, freezing, discharge of hydrothermal fluids, etc. Author holds the opinion about the leading role of
దీని గురించే
geological
వెళ్తే కనుక
factors
ఎంత అడుగుదాకని వెళ్ళలేదు
in water.
ఒకసారి వాడి గుర్తే మరి ఎప్పుడు
Inherit chemical composition of surface water from ancient sedimentary basins. Following this principle, the chemical evolution of the hydrosphere would have a more dramatic character than previously assumed. If we accept this circumstances, the salinity of ancient basins is a reason to explain the formation of water composition in many cases. I sent some key ideas about my methods. The first, formation of water inherit chemical composition of surface water from sedimentary basins. Salinity of ancient basins is the reason to explain the formation of water composition in many cases. The second, hydrochemical analysis of hydrological sections for every sedimentary basin by excluding the factors in connection with infiltration gives the possibility to compare the water of sedimentary origin in the geological time and space. The third, the principal tendencies are in the decreasing in salinity and decreasing calcium content during the geological time, and difference in water salinity between northern and southern hemisphere. These very interesting tendencies during the time and space. Formation water records the processes of pole migration, climate changes, and volume of hydrosphere. These global events have important implications not only for modeling of the chemical history of the ocean and sedimentary basins, but also for explanation of extinction periods and the many aspects of geology that depend on the composition of the ocean and the peripheral basins. Note this hypothesis that attempts to explain the chemical composition of groundwater based on changes in the composition of surface water. The first, volume of hydrosphere and dissolved salt, the first, in geological time. Cryogenic and freezing of water, salt deposition and dissolution of evaporites, is the first discharge of hydrothermal fluids. Evolution, the first key factor, evolution of hydrosphere. No, many scientists accept that ocean volume changed in the geological time. The main increase in volume was in Mesozoic time. According to the hypothesis, the ancient ocean was more than saltier than modern. This is some hypothesis, but hydrogeologists accept the hypothesis D because this model is most consistent with hydrogeological data. You see the situation with model D, but great increasing in volume of hydrosphere in Mesozoic time. Another component, calcium content. This is decreasing calcium content during the geological time. For Mesozoic time, some scientists showed that content of calcium decreases during Mesozoic and Cenozoic time. You see this diagram. Calcium magnesium ratio during the geological time with decreasing in magnesium content related to calcium content. The second idea, cryogenic brine formation. You know about snowball Earth hypothesis. Snowball Earth glaciations were a series of ice ages during the Neoproterozoic era on geological time scale, many confined to the Cryogenian period. This ice age was thought to have been so profound that perhaps the entire surface of the planet froze over from the poles to the equator. The estimation of the salinity profile of the Paleocean when the significant part of water turned into ice, significant part of fresh water turned into ice, is hard to define, but in shallow pools with a large thickness of ice, saturated brine web can form. As sea ice crystallizes on the surface, the dense residual brine sinks and saturates the effective porosity of the sediment. Consequently, these brines can be the basis for highly concentrated water of Paleozoic sedimentary basins. Data of the distribution of strong brines up to 200 grams per liter and above in the Precambrian rock of the Canadian, Scandinavian shelves, crystalline massive of East European and Siberian platforms are widely known. Against this background, the data of the chemical composition of water in crystalline massives of the African continent, where mainly fresh water is distributed, appear to be a sharp dissonance. The explanation of this phenomenon is lie in tracing the southern and northern magnetic poles ancient movements in Phanerozoic together with documented climate conditions of ancient times. At the end of the Proterozoic and early Paleozoic, the African continent was located in the southern polar zone. At this time, powerful glaciers formed on its territory. In the late Paleozoic, glaciers began to melt, filling the cavities of crystalline rocks and adjacent sedimentary basins with fresh water. On the left picture, you see the position of southern pole on the Sahara region, when crystalline massive of North Africa contained the fresh water. Later, this pole moved to the South Africa. In the Carboniferous, the glacier was discovered in the South Africa region. And now, South Poles on the Antarctica. What is this? It's very interesting phenomena where fresh underground water in African crystalline massives. Comparative study of the pole position. Pole position means great glaciers in different continents. This suggests that the geological history of the African continent has been particularly favorable for the accumulation of fresh water, in some cases ultra fresh, in potential less than 110 grams per liter. Waters in Paleozoic and later their preservation despite on the modern harsh arid condition in the region. This washing of this crystallization in Paleozoic leads to this situation. The translation of the Paleozoic seas and not affect the highly elevated African crystalline massives where fresh water was preserved. The Ordovician glaciation is suitable to explain this situation with hydrogeology, hydrochemistry of African crystalline massives. The third factor, evaporation. Extraction of salt into evaporate deposit would have resulted in lowering of seawater salinity in global aspect, but evaporation can form the strong brines in sedimentary basin. The only natural mechanism for getting salt out of seawater is evaporation. The initially high salinity of ocean must have declined in parallel with development of sedimentary basin and climatic condition capable of forming and preserving the great saline giants. Three distinct stages of salt accumulation are recorded in the Paleozoic, Cambrian, Devonian, and Permian, during which salt-bearing deposits of the Caspian, Ural, Dnieper-Donetsk basin, Western Europe, and North America are formed. The Mesocenozoic is characterized by the scattering formation of relatively small salt basin in the late Jurassic and Neogene. A salt accumulation geological history is the projection of alkali must be occurred in shallow marine and lagoon environments. Such typical sedimentary basins were shallow, like seas, Paleozoic and epicontinental seas, Mesozoic. Otherwise, the Mesozoic basins are characterized by epicontinental marginal seas and ocean. The question of the reason for sharp increase of the volume of the hydrosphere in the Mesozoic remains unclear. It can be postulated that large-scale halogenesis and increase in the volume of water in the Mesozoic sharply reduced the salinity of the ocean and intercontinental seas. Now, this is a diagram of Emily and Mayer about sedimentary basin evolution. To Paleozoic, there are marine basin, and in Cenozoic, and especially in Mesozoic, and especially in Cenozoic, there are basic Aldacostream sedimentary basin are distributed. It's very interesting paradox that marine that evaporates deposed in the marine sedimentary basin in Paleozoic. It means that that salinity of Paleozoic ocean and seas was more than in modern ocean. That it's very difficult to get salt deposits in the Cenozoic seas. What example in change of the composition of groundwater for the Eastern European platform over time? The limitation of carbonate rock leads to the removal of calcium from water and salt-bearing rocks to the removal of natrium and chloride. You can see that salinity was constant during the Paleozoic, great salinity, and after Permian deposition of salt, we have the decrease in salinity for Jurassic and Cenozoic. On the contrary, salt calcium content decreased during Paleozoic period to line decreased during Paleozoic period. After that, it slowly decreasing to Paleogene and Neogene period. This diagram shows that deposition of carbonate leads to the removal of to remove calcium, and deposition of salt rock leads to remove of chlorine salts, chloride salts. The first factor brines in hydrothermal systems. No, you know the hydrothermal system origin is system are in rifting system. Rift basin. This is faulting of Earth's crust. With it provides the penetration of water to the depths, with forming special condition in fast separation, for example, and other processes. What this is intrusion of the surface water to the depths leads to increasing of temperature and pressure, and there is some and the changing in physical chemical condition leads to phase separation, for example. if the intrusion of fresh water on the continent, for example, the Great Falls in South America, you can see the fresh water go to the fault zone, drifting zone, and some water penetrate to the high temperature zone on the depths. On the contrary, the penetration of salinity brines of ocean to the rifting faults leads to the forming of vapor water and high salinity brines. What is fast separation in Mediterranean-rich hydrocarbon system is highly sensitive to dynamics of surface pressure and temperature condition, and it has a significant impact on hydrogen concentration of hydrothermal fluids. Salinity of fluids venting from mid-ocean reach changes from 1 to 80 gram per liter, according to investigation of hydrogeologists. So this is a description of formation of brines in hydrothermal systems. When fluid salinity often deviates from the seawater value pointing to phase separation and segregation phenomena at depth. When seawater is heated and intersects with two-phase boundary, it splits into low salinity vapor and the higher salinity brine phase. Segregation of this phase can result in the venting of fluids that have a higher or low salinity than seawater. Observed when fluid salinity vary between 1 to 20% of seawater. 20% is 200 grams per liter. Boiling can occur at when fields located at water depths shallower than 3,000 meters. Such shallow boiling and condensation process in combination with brine extraction into the upwell zone are thought to be the reason of high spatial and temporal variability in when fluid salinities. When the vapor production stops because the system is pulled to the one-phase region, the brines could settle to form a layered system. These brines slowly mix with hydrothermal fluids of seawater salinity forming to the widest fissure to produce the high salinity fluids obtained in some hydrothermal vent. Well, this is example from Red Sea, pattern and magnitude of the variation in the composition of seawater suggests that seawater fluxes through mid-ocean ridges have played a major role in the evolution of seawater during the past 600 million years. In this diagram, you see the high salinity brines that as just as pillow lie on the bottom, and above of this pillow of brines, we have the normal salinity seawater with 40 grams per liter in the Red Sea. This is dense brine can create the pillow from normal seawater salinity and sediments. And after that, we can discuss the comparative method of comparative hydrogeochemistry. Experience based on study of individual basin is insufficient to understand formation of water region. There is no correlation between water composition and lithology of rocks. Comparative hydrogeochemistry gives a key to find consistent factors that govern the water salinity level in every basin. However, there is a general trend in changing the chemical composition of waters in sedimentary basins of marine genesis, decrease in salinity, a decrease in calcium concentration during geological time. What we can consider the some sedimentary basin during the geological time. In the Paleozoic sedimentary basin, you can I can take uh, some sample from Canada, Algeria, Russia. If, you see the common salinity is 200, above 200 gram per liter. Calcium content about 40 gram per liter. This is Willis from Canada, Hasimus, Algeria, Baltic Basin, the Scandinavian Baltic Basin, East Siberia, and Kimberlite pipe. This is Kimberlite. This content in Siberia content the high salinity brine. If you go to the late Paleozoic sediment, the Devonian and late Carboniferous Permian, salinity of Martian water decreases to 200, 250 50 gram per liter. Calcium content in twice less than in early Paleozoic sediment, 20 to 25 gram per liter compared with 40 gram per liter. Statistical chemical parameters of the North American and Eastern European platform show their similarity. Decreasing mineralization won in connection with melting of ice and global evaporation process that occurred in the late Paleozoic time. So deposition works as a machine that removes salt from the hydrosphere. Near below we can see Russian and Ukrainian sedimentary basin with salinity 250 per gram per liter, calcium 20 gram per liter, magnesium 2, 3 or 1 to 3 gram per liter. In comparison with Paleozoic and Mesozoic sedimentary basins, Ionosphere was larger in volume than Paleozoic ocean origin, and water salinity was decreasing dramatically. Some geologists think that this time was time of origin of ocean with great increasing in volume of hydrosphere. This time is named as oceanization of the Earth when the ocean origin. Extended Mesozoic sedimentary basins are comfortable to study the influence of hydrothermal injection into sedimentary section. Let's say video. What do you see? TDS salinity 30 gram per liter, in some basin more than 500. North Caucasus and the Middle East basin we can high density brines. Calcium content less than 5 gram per liter, just great decreasing in comparison with Paleozoic. You see the great decreasing in salinity. Cenozoic, the same trend, decreasing in salinity, and salinity of many basins, especially in origin regions. Something like modern ocean salinity or less than modern ocean salinity. For example, 15 in North Caucasus, 15 gram per liter. In some Caspian, where we have the very, very complex situation with translation irrigation. We have this great variable salinity from 10 to 200 grams per liter. After that, we can say that the history of subsurface water is an integral part of the history of the Earth, and their comparative study will allow to understand many aspects of its evolution. Summary and discussion of formation water region and consequences of to understand some aspects of its Earth's history, especially about evolution of hydrosphere. Transition of water to ice, removing fresh water from the hydrosphere, and the on the contrary opposite process carbonate salt deposition, removing fluor and calcium from seawater. This is deposition in rock. This salt leads to the decreasing in salinity. This is in connection with the evolution of sedimentary basins from the shallow extended basins to the deep limited basins. Hydrothermal processes in the different basins downstream of fresh water on continent and saline water ocean into falls of ripple system. We have the difference in salinity of continental rifting hydrothermal system and rich and middle rich ocean system. Conclusion. Earth's history is more dramatic than we suppose. Formation water composition recorded many events in history of sedimentary basin from its foundation to its filling. We can understand the evolution of the Earth and its part more completely if we learn the read formation water analysis. Analysis in the whole geological format. The history of the Earth teaches us lessons that we must take into account today. Thank you very much for attention. Bye.